Well, 9.4 part 2, we're going to continue on graphing these systems of linear inequalities in two variables. So we're just going to go in. So first thing we want to do over here is we want to go ahead and graph the first equation. That is, we have y is greater than x. So first thing we want to do is graph y equals x. And we're going to use a solid line here because we have the greater than or equal to. So here we can think of this as y equals x plus 0. So we know we have a intercept at 0, 0. That is our y-intercept. Our slope is 1 over 1, so we can go up 1 and over 1 and get another point. Draw the line that goes through these. And we are good. Okay, now here we need to pick a test point and put it back in the original equation. We can't pick 0, 0. We can't pick the origin because it's on the line. So I'm going to pick 5, comma 0. Now we're plugging this back in the original. So is 0, plugging that in for y, greater than or equal to 5? Answer, well, 0 is not greater than or equal to 5. So we don't want this point to be part of our solution set, so we're going to shade on the far side of that line. Okay? Now graphing the second line here, because we're going to have y equals negative x plus 4. Okay? So if y equals negative x plus 4, this has y-intercept 4. So 0, comma 4, we're going to plot that point. And then the slope is negative 1, so we can go down 1 and over 1 to get the next point. And draw the line that goes through those. That's that right there. Now we want to take a test point. We can pick 0, 0 for this, so plane that back in. Do it up here. Is 0 less than or equal to negative 0 plus 4? So really this reduces to, is 0 less than or equal to 4? Answer is yes. So because the origin satisfies that equation, it is part of our solution set. So we're going to include that. So we're going to shade below the line that we just graphed. And we're only going to shade in the region that's already shaded by that first inequality. So here, that right there is our solution region. And I'll kind of outline it again. We have this line, and this line right here, and this region right there. That is the solution region, the intersection of the two individual regions. Now the last thing we need to do is we want to solve for this intersection point right there. So we're really solving this system of equations right here. We have x equals y, and we have y equals negative x plus 4. So we can use substitution to plug x in for y, I guess, because x equals y. So we can say x equals negative x plus 4. Add x to both sides. That gives us 2x equals 4 divided by 2. We get x equals 2. So the x-coordinate of this vertex is 2. Plug this back in. Well, because x equals y, the y-coordinate is 2. So this vertex right here, this intersection point of the two lines, is the ordered pair 2, 2. Okay, so that was that one. So looking at this next one, let me move this over. We have two lines. The first one we have is x plus y is less than 1. So here we're going to be using a dashed line, so I'll just draw a little dashed line to remind me. And we're going to graph x plus y equals 1. So I can solve this for y by subtracting x from both sides. So we get y equals negative x plus 1. Now recall that this is a line with y-intercept 0, comma 1. So our intercept's there. Slope negative 1, so we go down 1 and over 1. That gives us the second point. We're using a dotted line that goes through those 2 points. That's that. So last thing we need to do is pick a test point. Always pick the origin if you can. So 0, 0. Plugging that back into our original equation. Is 0 plus 0 less than 1? Well, 0 is in fact less than 1. So we want that to be part of our solution set. So we're going to include that. So we're going to have to shade below the line right there. Okay. Now the next one, we have x minus y is greater than 2. So since we are greater than or equal to 2. So we have greater than or equal to, so we're going to use a solid line. So we have x minus y equals 2. Subtract our x. gives us negative y equals negative x plus 2, and divide everything by negative 1 here, and we get y equals x minus 2. So this is a line with y-intercept 0, negative 2. Slope 1, so go up 1 and over 1. So this has a solid line, so we can draw that solid line in there. Pick a test point. Well, 0, 0 is not on the line, so plug it in. Is 0 minus 0 greater than or equal to 2? Well, 0 greater than or equal to 2. It is not, so we do not want to include that point in our solution set, so we're not shading above the red line, we're shading below. But our real solution region is the one that's the intersection, so it's just this little triangular wedge that keeps going down right there. So that's our solution region. So the last thing we want to do is we want to go ahead and find what the vertice of that is, where the intersection point is, and that's nothing more than solving the system of equations from here right here. We can solve x plus y equals 1 and x minus y equals 2. We can use elimination here to add these together. 2x, the y's cancel, equals 3, divide by 2. So x equals 1.5. So this intersection point right there, x is 1.5. To find the y, we can plug this back in. So we go ahead and plug it in the first one, that's fine. So 1.5 plus y equals 1. Subtract 1.5. We get y equals negative 1/2. So negative 0.5. And that is the intersection point of those two lines. So that's the vertex of those. Okay. So last one we have is this, and really we're not doing anything more than graphing lines using a solid line if we have greater than or equal, less than or equal, using a dashed line if we have greater than or less than, and then picking test points and shading. So go ahead and do this last one. We have the first line. So we have, well, let's start at this bottom. If we have x is greater than or equal to 0, first off we have x equals 0. That's a vertical line right here. X being greater than 0, we're going to be shading this way. So we're not going to be shading over here, we're not going to be shading over here just by x is greater than 0. Look at the second one. Y equals 0 is a horizontal line that runs like this. Well, if y is greater than 0, we're going to be shading up here, so we're not going to be shading down here either. We're just looking at this. So because we have greater than or equal to, this is one of our lines, or this is a boundary piece. This is a boundary piece as well. So we're only looking up here in this top right quadrant. Now to get the other two pieces, and this gives us one of our vertices already, that vertex down there is 0, 0. That gives us 1. So looking at this first line, go ahead and do this in red. If we have x plus 2y equals 12, we're going to use a solid line because we have less than or equal. Now here I'm going to just use my intercepts because it's not solved for y. So sticking 0 in for x, 0 plus 2y equals 10. Well, 2y equals 10, divide by 2. Y equals 5. So 0, 5. 1, 2, 3, 4, 5. 0, 5. Now this gives us another vertex that we have 0, 5. This may not be one that we use because it might get sliced by the other one, but at least we have it. Then I'm going to find the x-intercept by plugging 0 in for y. So we have x plus 2 times 0 equals 10. So x equals 10. Okay. So we're out here using a solid line. This also gives us this point 10, 0. So we know that's on there. Now picking a test point and plugging it in here, we're going to choose 0, 0. So is 0 plus 2 times 0 less than or equal to 12? Well, 0 is less than or equal to 12, so we're going to be shading below this line. So we're not looking outside of there, we're looking in this triangular piece. Now, for the last little piece, we need to graph this last equation right there. So we have 2x plus y equals 12. Let me write this down. 2x plus y equals 12. We're using a solid line because we have less than or equal to. So just like we had with the last one, I'm going to pull this up for a minute and find some intercepts because it's not solved for y. So we have our x, we have our y, plugging 0 in for x. 2 times 0 plus y equals 12. That gives us y equals 12. So 0, 12, that is a point on the graph. That is up here. 0, 12. So because that's outside of our solution region, it's not going to be one of our vertices. Now plugging 0 in for y, we're going to be finding that x-intercept. So plugging 0 in there, we have 2x plus 0 equals 12. So this really goes away. Divide by 2, we get x equals 6. 6 comma 0. That's that point right there. 2 points uniquely determine a line, so we can draw the line that goes through that right there. Pick a test point again, 0, 0, plug it in, is 2 times 0 plus 0 less than or equal to 12? Well, yep, yes it is. So, that gives us that. So, we want to shade underneath this. So, we're underneath the red line, underneath the blue line, and above this line. So, this little region right here is our solution region. So, our vertices, we have 0, 0, we have 0, 5, we have 6, 0, and then we have some point right here. So to find that vertex right there, we want to think which two lines is that the intersection point of? Well, it's the intersection point of the top two lines. So we need to solve the system x plus 2y equals 12 and 2x minus y, plus y equals 12. So we're just copying these two equations over there. So we got 3 of the 4 vertices, and we have a little nice pinned-in solution region here. So solving this, I'm going to eliminate the x's. So I'm going to multiply the top one by -2. So we get negative 2x minus 4y equals negative 24. Add these up. The 2 x's cancel. Y minus 4y is minus 3y. 12 minus 24 is negative 12. Divide by negative 3. We get y equals 4. Okay. So we know the y value there is 4. Okay. To find the x, we can plug this back in. So I'll plug into the top one. X plus 2 times 4 equals 12. So x plus 8 equals 12. Subtract some 8s. We get x equals 4. So that point right there is 4, 4. So our vertices are anywhere these lines intersect that are touching our solution region. So right here we have this is 4, 4. This is 6, 0. This right here is the origin 0, 0. And this is 0, 5. So that's, I don't know. That is how you do that one. Alright, good luck. Upcoming will be the test review in video format.